Welcome to this channel. I am Omotola Fayomi, and in the next minutes, you are going to completely master acid, bases, and salt for your JAMB examination. This is one of the most frequently tested topics in JAMB Chemistry, and yet it is one of the most straightforward. Once you know the rules, we cover pH, indicators, titration, salt preparation, and buffer solutions, all in focus minutes. If you are writing JAMB, bookmark this video. If your friend is writing JAMB, share it right now. Let us get your A grade started. Let us start at the foundation. What is an acid? JAMB tests three definitions, and you need to know all three. Arrhenius definition, the simplest and oldest. An acid produces hydrogen ions H+, when dissolved in water, and a base produces hydroxide ions OH-. This works perfectly for aqueous solutions. HCl in water gives H+ and Cl-. Sodium hydroxide in water gives Na+ and OH-. Clean and simple. Bronsted Lowry definition, brother, an acid is a proton donor and a base is a proton acceptor. This is the definition that JAMB uses most frequently in calculations and equation questions. Notice it covers reaction without water too. Lewis definition, the broadest of all, an acid accepts an electron pair. Note, an electron pair, and a base donates an electron pair. This explains reactions where no proton is transferred at all. Properties of acid at JAMB test: they taste sour, have pH less than 7, turn blue litmus paper red, react with metal to produce hydrogen gas, and react with carbonate to produce carbon dioxide gas. Now, the distinction between base and alkali. JAMB loves testing this. Many students confuse them, but once you hear this explanation, you will never get it wrong again. A base is any substance that neutralizes an acid. It is a broader term. A base can be insoluble in water. Copper oxide is a base. It neutralizes acid, but it does not dissolve in water. Iron oxide and calcium carbonate are also insoluble bases. Note, an alkali is a soluble base, a base that dissolves in water and produces hydroxide and OH-. Sodium hydroxide, potassium hydroxide, calcium hydroxide are alkalis. Ammonia dissolves in water, is also a weak alkali. The key sentence to memorize: an alkalis are bases, but not all bases are alkali. If a student in your class gets that wrong in JAMB, it is because they did not watch this video. Properties of alkali: bitter taste, soapy feel, pH greater than 7, red litmus paper turn blue, and react with ammonium salt to release ammonia gas, which has that characteristic sharp smell and turns dark red litmus blue. Note that. So what are the strong and weak acid and bases? And now, this is critical. The difference between strong and weak acid, and this is not the same as concentrated and dilute. The strong acid is one that completely dissociates in aqueous solution, that's in water. Every single molecule breaks apart into ions. HCl in water gives 100% H+ and Cl- ions. HNO3, H2SO4 all fully dissociate. The 6 strong acids are HCl, HBr, HI, HNO3, H2SO4, HClO4. Memorize these 6. The weak acid only partially dissociate, ethanoic acid in water. Only about 1% of molecule breaks apart. The rest remain as molecule. This is why you see the reversible arrow in their equation. Strong bases, sodium hydroxide, KOH, calcium hydroxide, they fully dissociate. Weak base, ammonia in water. Reversible reaction, partial ionization. JAMB trap is that strong does not mean concentrated. A concentrated weak acid can have a higher pH than a dilute strong acid. The word strength and concentration are completely different properties. What about the pH scale? The pH scale is one of the most fundamental concepts in this topic and is tested in almost every JAMB paper. The pH scale runs from 0 to 14. 0 is the most acidic, 14 is the most alkaline, 7 is the neutral, as in pure water. Everything below 7 is acidic. The lower the number, the more acidic. Lemon juice is about pH 2, quite acidic. Vinegar is about pH 3. Stomach acid is pH 1 to 2, very acidic indeed. Everything above 7 is alkaline. Baking soda solution is about pH 9. Household bleach is about pH 12. Concentrated sodium hydroxide is about pH 13 to 14. pH formula is pH equals negative log of the hydrogen ion concentration. This means pH is equal minus log H+ concentration. The square bracket means concentration in mole per dm cube. An important property, the pH scale is logarithm. That means pH 3 is 10 times more than acidic than pH 4 and 100 times more acidic than of 10. This multiplier of 10 per pH unit is frequently tested in JAMB. Now let us put the formula into action with calculations that JAMB sets repeatedly. Example 1 is this. What is the pH of 0.01 mole per dm cube hydrochloric acid? Step 1 is that HCl is a strong acid, so it completely dissociates. That means concentration of H plus ion equals the concentration of HCl, which is 0.01 mole per dm cube. 0.01 is the same as 10 to the power of negative 2. So pH equals to negative log of 10 to the minus 2, which equals positive 2. pH equals to 2. JAMB speed trick, which whenever the concentration is 10 to negative n, the pH is simply n. 0.01 mole per dm cube equal to 10 to the minus 3. So pH equals 3. Instant answer. Example 2 is pH of 0.01 mole per dm cube sodium hydroxide. Sodium hydroxide is a strong base, so OH minus concentration equal to 0.01 equal to 10 to the power minus 3. So POH in this case, because it's P is OH minus, equals to 3. pH will now be 14 minus POH. That's 14 minus 3, which is equal to 11. Remember, for alkalis, use pH equal to 14 minus pH. For acid, use pH equal to negative log of H plus. Remember, for alkalis, use pH equal to 14 minus pH. For acid, use pH equal to negative log of H plus. Two different routes for two different types. What about indicators? These are chemicals that change color depending on whether the solution is acidic or alkaline. JAMB test indicator colors in almost every paper. Litmus, the most famous indicator, it turns red in acidic and blue in alkaline. Simple, but litmus is not precise enough for titration. Phenolphthalein, colorless in acid and neutral, but turns pink or red in an alkaline solution. Remember, phenolphthalein shows color change at a high pH, so it is used when the endpoint is alkaline. Methyl orange, red in acid, orange at the transition point, and yellow in alkaline because it changes color in the acidic range pH 3 to 4. It is used when the endpoint is acidic. The JAMB question about choosing indicators for titration is absolutely crucial. Here is the rule. Strong acid plus weak base gives an acid salt. Use methyl orange. Weak acid plus strong base gives an alkaline salt. Use phenolphthalein. Strong plus strong either works. Weak plus weak neither gives a sharp endpoint. So universal indicator gives you the approximate pH using a range of colors. It is a mixture of several indicators giving the full rainbow from red to purple. Neutralization reactions. Neutralization is the reaction where an acid and a base react to form a salt and water, and this is the most important reaction in this entire topic. The net ion equation, the most fundamental equation in acid-base chemistry, is H plus OH minus gives H2O. One proton plus one hydroxide ion gives one water molecule. Every neutralization, regardless of which specific acid and base you use, has this at its core. HCl plus NaOH gives sodium chloride, common table salt plus water, and this is a strong acid plus a strong base, so the salt solution at the head point is neutral, pH equals 7. When acid reacts with a carbonate like calcium carbonate, the products are salt, water, and carbon dioxide. This CO2 turns lime water milky, and that is the standard test for CO2. When acid reacts with a metal like magnesium, the products are salt and hydrogen gas. Hydrogen bonds with a squeaky pop when you test it with a light splint. That is the test for hydrogen gas. Importantly, when a weak acid like ethanoic acid reacts with sodium hydroxide, the sodium ethanate salt produced makes the solution alkaline, not neutral, because of salt hydrolysis. This is why phenolphthalein is needed. So the titration technique is tested both theoretically and in data analysis in JAMB. So understanding every step is essential. The key apparatus are a burette holds the solution you are adding. It has a tab at the top and reads to 0.05 cm cube. A pipette delivers an exact volume, usually 25 cm cube, into the conical flask. A white tile placed below the flask helps you to see color changes clearly. The procedure: clean and fill your burette, read the initial volume, use a pipette to transfer exactly 25 cm cube of your alkali or acid into the conical flask. Add 2 or 3 drops of indicator. Now the critical part is that add the solution from the burette slowly as you approach the endpoint. Near the endpoint, add dropwise, 1 drop at a time. Swirl the flask constantly. The endpoint is when 1 drop causes a permanent color change that does not disappear while swirling. Record the final burette reading. The titer equals to final minus initial. Do the least 3 titrations. Select the concordant titer, which we call titer value, and that agrees within 0.1 cm cube of each other, and calculate their mean. Never include the rough titer, the first one titer, in your mean. And now the calculations that appear in every JAMB chemistry paper on this topic. Master this formula and you will always call the titration calculation max. The master formula is C1V1 divided by N1 equal C2V2 by N2 divided by N2, where C is the concentration in mole per dm cube, V is the volume in same units, and N is the mole ratio from the balanced chemical equation. Example 1, 25 cm cube of sodium hydroxide is exactly neutralized by 20 cm cube of 0.1 mole per dm cube HCl. Find the concentration of sodium hydroxide. Step 1 is that you write the equation HCl plus sodium hydroxide gives NaCl plus H2O. The mole ratio is 1:1. And the step 2 is that apply C1V1 equals C2V2 because the ratio is 1:1. Step 3 is 0.1 times 20 equals C2 times 25. Step 4 is that C2 equals 2 divided by 25. Step 4, C2 equals 2 divided by 25 equals 0.08 mole per dm cube. Example 2, sulfuric acid reacts with sodium hydroxide, a 1:2 ratio. The formula becomes C acid times V of acid divided by 1 equals C base times that V of base divided by 2. The denominator changes with the mole ratio. Your first step approach every time. 1, write equation. 2, find mole ratio. 3, apply C1V1 over N1 equals C2V2 over N2. 4, make the unknown the subject of the formula. 5, substitute and calculate. Repeat this process for every JAMB titration question. What about salt preparation? 4 methods, all tested in JAMB, and each is used in specific situations. Method 1, for soluble salt from acid plus alkali like sodium chloride from HCl and sodium hydroxide, use titration. Use the exact volume determined from titration. Mix without indicator, then evaporate the water and crystallize to get the salt. This method is used when both acid and base are soluble. The second method, for soluble salt like copper sulfate from an insoluble base like copper oxide, add excess solid copper oxide to dilute sulfuric acid. The excess ensures all acid is used up. Filter off the unreacted solid, then evaporate to crystallize these blue copper sulfate crystals. Method 3, for insoluble salt, use precipitation. Mix 2 soluble solutions whose ions combine to form the insoluble salt. For example, lead nitrate solution plus potassium iodide solution gives lead iodide precipitate. Filter, wash with distilled water and dry the precipitate. Method 4 is direct synthesis. Heat the metal with the non-metal directly. Sodium chloride plus chlorine, though it is not something you can practice at home, gives sodium chloride. This is used when other methods are not. Understanding types of salt is straightforward but critical for JAMB questions on salt identification. A normal salt has all the acidic hydrogen atoms replaced by metal ions. Sodium chloride, copper sulfate, potassium sulfate, all normal salt. An acid salt forms when a polybasic acid, one with more than one replaceable hydrogen, is only partially neutralized, like sodium hydrogen carbonate is an acid salt because one of the two hydrogens in H2CO3 has been replaced. NaHSO4 is another example, and a basic salt contains both the anion from the acid and the hydroxide or oxide, like basic copper chloride. This form when there is an excess of base during neutralization. Now, solubility rule. This comes up in JAMB regularly for predicting whether a precipitate forms. Rule is that all nitrates are soluble, all sodium, potassium, and ammonium salt are soluble. Chlorides are soluble except silver chloride and lead chloride. Sulfate are soluble except barium sulfate, lead sulfate, and calcium sulfate. Carbonates are generally insoluble except sodium, potassium, ammonium carbonate. Hydroxide are generally insoluble except sodium hydroxide, KOH, and calcium hydroxide. What about buffer solution? Buffer solutions are now appearing more frequently in JAMB, so pay close attention to this section. A buffer solution resists changes in pH when small amount of acid or alkali are added to it. It does not prevent pH change completely, it just minimizes it. An acidic buffer consists of a weak acid plus the salt of that weak acid, which provides the conjugate base. The most common example is ethanoic acid plus sodium ethanoate. Both the weak acid and its conjugate base are present in large quantities. When you add acid ion to this buffer, the ethanoate reacts with the acid H plus to form ethanoic acid molecule. The pH barely changes. When you add alkali OH minus, the ethanoic acid molecules react with OH minus to form water and ethanoate ions. Again, pH barely changes. An alkaline buffer uses ammonia with base plus ammonium chloride, its salt. Blood uses a carbonic acid hydrogen carbonate buffer to maintain pH between 7.35 and 7.45, vital for life. Here is your complete cheat code for acid, bases, and salt. Every key fact in one place, ready to be burned into your memory before your JAMB exam. pH formula: negative log of H plus concentration for strong acids. If the concentration is 10 to the negative n, pH equals n directly. For alkalis, pH equals to 14 minus pOH. Indicators: litmus red in acid, blue in alkali. Phenolphthalein is colorless in acid, pink in alkali. Methyl orange, red in acid, yellow in alkali, orange in between. Titration formula: C1V1 over N1 equals C2V2 over N2. Always write the balance equation first to get the mole ratio N1 and N2. Solubility shortcuts: all nitrates soluble, barium sulfate, AgCl, Pi2, PbCl insoluble, most carbonates insoluble except Na, K, ammonium, most hydroxide insoluble except sodium hydroxide, potassium hydroxide. Ion test: silver nitrate in nitric acid, white precipitate of silver chloride confirms chloride ion. Barium chloride in hydrochloric acid, white precipitate of barium sulfate confirms sulfate ion. These tests are classic JAMB. Every one of these has appeared in recent JAMB papers. 1. Acid plus any carbonate always gives CO2 gas, which turns lime water milky. This is your confirmation test for CO2. 2. Remember the pH scale is logarithmic. Each whole number step means 10 times the change in hydrogen ion concentration. This magnifies the meaning of small pH differences. 3. Concordant titers must agree within 0.1 cm3. The rough titer is never included in the average. JAMB test this in practical analysis question. 4. Indicator rule: methyl orange for strong acid with weak base, phenolphthalein for weak acid with strong base. Acid endpoint equal methyl orange, alkali endpoint equal phenolphthalein. 5. Barium sulfate is so insoluble that it is used as the barium meal in X-ray imaging and it does not dissolve and is safe to swallow. Silver chloride is used in black and white photography, light sensitive and insoluble. 6. The enthalpy of neutralization for any strong acid reacting with any strong base is approximately 57 kJ per mole. It is always negative because neutralization is exothermic, it releases heat. Final bonus, conjugate acid base pairs from Brothelori theory. When an acid donates a proton, it becomes its conjugate base, which differs by just one hydrogen ion. ACl donates H plus to become Cl minus, its conjugate base. Ethanoic acid donates H plus to become ethanoic ion. When a base accepts a proton, it becomes its conjugate ion. Ammonia accepts hydrogen ion to become ammonium ion. Water accepts hydrogen ion to become hydrozonium ion, H3O plus. Identify conjugate pairs in any equation. Just look for two species that differ by one hydrogen ion. That is your conjugate pair. And identifying them correctly earns you mark in JAMB. Well done. You have just completed this masterclass in acid, bases, and salt. One of the most important and most frequently examined topics in JAMB chemistry. You now know 3 different definitions of acids and bases, and the pH scale, and how to calculate pH, how to choose the right indicator for any titration, how to perform and calculate titration results, 4 methods of salt preparation, solubility rules, and buffer solutions. That is everything. If this video helped you today, and I know it did, please like this video, subscribe, share it with every chemistry student you know, and also, as I've said, subscribe for more rapid revision walkthroughs on every topic in JAMB chemistry. Comment below which aspect of this topic was the most helpful for you. Was it the pH calculations, the indicator table, or titration formula? Remember, you are not just born to pass JAMB. You are born to excel, even in chemistry, in your career, in your relationships, in your faith. God bless you richly. Go and get that A grade. I will see you in the next video. Cheers.